Hello students, in this class we will discuss about the single phase induction motor. Up to now we will discuss about the three phase induction motor. That means the induction motor works on the three phase supply. But name itself single phase induction motor. Name itself represents works only single phase AC supply. Three phase AC supply and single phase AC supply. So compare with three phase AC supply, single phase AC supply. Single phase AC supply is highly applicable and highly used applicable or used due to more economical, less power consumption. More economical and less power consumption. Less power consumption. But in the construction point of view, it is different. Somewhat different with three phase and single phase. So any motor consisting of the stator as well as rotor. So first, the single phase induction motor consisting of the stator. Stator is simply the single phase supply, AC supply is given. AC supply is given directly for the stator. Look at here, this input power is given to the main winding. So it consisting of main winding. It consists main winding. So this is the main winding is nothing but the stator. This main winding is nothing but the stator. Simply this is the stator. Next, rotor. Rotor. Here it is connected to mechanical load to the shaft. Simply the rotor, it is connected to, because it is rotates, our requirement is rotates, mechanical load. If it is a fan requires blades, okay, wings. So by the wings only we will get the air. So that is for the rotor only mechanical load is connected. Okay. Yeah. So, but we have a different, almost single phase induction motor construction is same as the three phase construction. Same as three phase squirrel gauge induction motor, not slip ring, squirrel gauge induction motor construction. But we have a different, that is windings are concentric windings. Here we are using concentric windings. We are using concentric windings. Why we are using concentric winding? Why we are not using the distributed winding like that the three phase induction motor means? Modifying the slot windings modification is possible. By that slot modification we will get more sinusoidal MMF, more sinusoidal magnetomotive force. Due to this more sinusoidal magnetomotive force, we will get more sinusoidal flux. Whenever the more sinusoidal flux is there, automatically the single phase induction motor works very efficient. That is the reason. The concentric windings only the reason for this. Okay. So the construction is same as squirrel cage induction motor. The constant windings only different. Next. So the construction, look at here. This is the stator. Main winding is the stator. Is nothing but stator, and this is the rotor. And we have the capacitor, centrifugal switch, and stator start winding. We will discuss about these three things later. Just keep, we are giving input power to the main winding and it is applied to the rotor. Next, working principle. So simply, any motor to run, the main requirement is the torque. Torque is the main requirement. So in order to produce the torque, the two things are important. That is, it requires two fluxes. Two fluxes rotates with some displacement. With some displacement. Consisting of the two fluxes, those two fluxes have rotates with some displacement. Then the any motor will rotate. So here generally we are giving single phase AC supply to stator. We are giving single phase AC supply to stator. Stator consisting of the windings. Then whenever the supply is given to the winding, automatically the flux will be produced. Stator flux will be produced. The stator flux is nothing but the alternating flux. Why it is alternating? It is the alternating supply. Then generally construction is like this. So here the stator, this is the, assume that this is the stator. We are giving single phase AC supply. We have the winding, we have conductors. Then automatically whenever supply is given to the windings, flux is produced, but alternating flux. And inside we have the rotor also consisting of the conductors, and this alternating flux is entering into the rotor. Then look at here, this flux will enter into the rotor. The flux, alternating flux is entering into the rotor. Rotor have conductors cuts the flux. Conductors cuts the flux by Faraday's law of magnetic induction. Faraday's law of magnetic induction. Faraday's law of magnetic induction, the flux will be cutted, and again EMF induces in rotor. EMF induces in rotor. Rotor also having the conductors. Then rotor currents will be produced. Next, wherever the EMF is produces, and those are short circuited rotor currents. Wherever the rotor current produces, then the rotor flux is also produces. Rotor flux is also produces. Simply. So we have produced. So to produce the torque, we get two fluxes. The first is the stator flux. The second one is the rotor flux. With some, if we create some displacement, automatically torque will be produces. The torque will apply on the rotor will rotates, right? And why it is called induction? So the stator flux entering into the rotor by the induction. So by the electromagnetic induction, that's why it is called induction machine. So by the induction, flux enter into the rotor. By the induction, flux enters into rotor. That's why it is called the induction motor. That's why it's called induction motor. So this is for any induction motor, that may be 3-phase induction motor or single phase induction motor. Next, but single phase induction, look at the title, why single phase induction motor is not self-starting motor. Generally, before that we will discuss some points here. 3-phase induction motor is self-starting motor, but single phase induction motor is not self-starting. We will discuss the reason. The reason is double field revolving theory. By the double field revolving theory, this is the theory, we'll explain it. Double field revolving theory. So this theory represents any alternating flux will be divided into two components. So here generally flux is given to stator. The stator flux will be divided into two components. Those are that components can be divided into maximum flux by 2 plus maximum flux by 2. The second component is minus maximum flux by 2. Okay. These two components rotates with synchronous speed, and this component also rotates with synchronous speed. But the rotation it rotates clockwise direction. And it will rotates anti-clockwise direction. It is in clockwise and it is in anti-clockwise. Then what happened? Look at here. Clockwise direction and anti-clockwise direction. So what happened due to this? At starting condition, look at here, the two fluxes, one 5m by 2, another one is minus 5m by 2. What happened? It is rotates with synchronous speed. That means 5m by 2 is rotates with synchronous speed in this direction, and minus 5m by 2 is opposite direction rotates this. Then what happened? Both will be cancelled. Due to this, both are cancelling each other fluxes. By this, what happened? The net rotating flux is 0. Net rotating flux is 0. Then net starting torque is also 0. Net starting torque is also 0. So what happened? The starting torque is become 0. Whenever the starting torque is 0, motor doesn't rotates. So that is the reason single phase induction motor is not self-starting motor. But 3-phase, it is a self-starting motor. The problem is occurred only for the single phase, not for 3-phase. Understand? So once again we will look at. Generally, we have a double field revolving theory in our magnetic system. That double field revolving theory, any alternating flux is divided into two components. That is maximum flux by 2 minus maximum flux by 2. Which represents, this is This is first component rotate with synchronous speed in clockwise direction, and second is rotate with synchronous speed in anti-clockwise direction. At starting condition, the both are same speed and opposite each other, then cancel each other fluxes. Net rotating flux is 0. Net rotating flux is 0. The net starting torque is also 0. That's why single phase is not self-starting motor. Self-starting motor. And so it is not self-starting motor. That's why we have to make it a self-starting motor. We have to make it self-starting motor. So how we can make it a self-starting motor? Making self-starting, so self-starting is possible self-starting is possible by making flux is rotating. We have to create the making flux is rotating flux. Flux must be rotated, not alternating flux. If it is single phase alternating, then it will be cancelled, not alternating. Self-starting is possible making flux is rotating, not alternating. Okay, right. So if it is if it is rotating, then only it will rotate in particular direction. It will rotate in particular direction. It will rotate in particular direction. So for that, to produce the rotating flux, so our requirement is to produce rotating flux. To produce the rotating flux, what is the condition to produce the rotating flux we required? The requirement is two alternating fluxes required. Two alternating fluxes is required. You have to produce a two alternating flux, but these alternating fluxes with some displacement. It required some displacement also. It requires some displacement also, right? So by that the resultant flux is alternating, right? So for that, we will produce, if you produce the two alternating fluxes, automatically it will possible. So to produce alternating flux, we have four methods. The first method is split phase induction motor. By making the induction motor is split phase induction motor, and second is capacitor start induction motor. Capacitor start induction motor. Third is capacitor start capacitor and induction motor. Capacitor start capacitor run induction motor. Next, fourth is shaded pole induction motor. Shaded pole induction motor. So by using these four methods, we will produce two different alternating fluxes with displacement. So first one is the split phase induction motor. First one is the split phase induction motor. and second one is the capacitor start induction motor, third one is the capacitor start capacitor and induction motor, fourth one is the shaded pole induction motors. These are the four methods we can produce the thing. So what happened, they will produce two different fluxes. The first flux is phi 1, you can take it as a phi 1, that is the flux is like this, phi m sine theta, and it will produce the second flux, that is phi m sine theta minus phi by 2. These two fluxes are produced. By using these two fluxes, we will get the rotating flux. Okay, these are the four methods. If we are discussing, it will take much more time. Just keep in your mind. The main thing is, by double field revolving theory, it is not possible. So now you will understand the first diagram. That first diagram is located here. So by using this capacitor and this starting winding, so initially we will put this capacitor and starting winding, central starting winding. So whenever it reach the normal speed, automatically centrifugal switch will be open, then the main winding is applicable. Okay, so to produce the two different fluxes, we are using this starting winding with capacitor with centrifugal switch, otherwise no required. So that's why at starting, so we will explain, at starting with this is about capacitor start induction motor. At starting with main winding with main capacitor and starting winding are used. Starting windings are used. Okay, once it reach the speed, once it reach the normal speed, starting winding is removed. Starting winding is removed. Then only it will rotate with main winding. That's why if you observe our fan is nothing but single phase induction motor. In that fan we are putting a capacitor. Understand? Right. Next. So what is the advantages of these single phase induction motor is, first advantage is it is simple construction. It consisting of the simple in construction and robust. It very mechanically highly robust and reliable. It consisting of the reliable operation. It is very reliable and it is cheaper, very cheaper for small rating machines. If you require small rating machine, small rating available up to 1 kilowatt rating. So up to 1 kilowatt rating, it is very cheaper. Yes, yeah. So these are the advantages. The applications. So it has more number of applications in our domestic, in our homes or office or anywhere. We are using the fans. Fans are only single phase induction motors. And in the vacuum cleaners, in our domestic we are using the vacuum cleaners to clean the surface. That is only simple the single phase induction motor. Next, washing machine also the single phase induction motor machine. And centrifugal pumps and blowers, centrifugal pump and blowers All are the applications of the single phase induction motors. So in our daily life we are using the and vacuum cleaners fan and vacuum cleaners and washing machines all are working those motors are nothing but the single phase induction motor. That's why it is very important. It is very important. Okay, this is about the single phase induction motor. Okay, thank you.